In this video, you're going to learn the anatomy of a commit in Git, or find out what happens when we make changes or save those changes in a Git repository. Now don't worry, if you're new to Git, you're still going to get the understanding of how Git works. But if you've been using Git for a while, you're also going to understand what happens in the background. So here we are within our glorious file system, and we can create ourselves a brand new Git repository. But for that, we're going to require a directory. So let's go through and create my_project. It can be a better name than that. We can move into that directory, and we can then run git init to create ourselves a brand new Git repository inside of my_project. When I go through and list the directory, so ls-la, we can see then that we have the dot and the dot directory and .git. It's .git that is my database. But I can go through and use ls-l uppercase A if we don't want to see those pesky little dot and dot directories, so we can focus on that .git directory, the hidden directory that contains all of my repository information. Talking of which, there really isn't any at the moment, because when I look at tree and .git, we'll see that this really is just a template with no extra content other than what would be in the template of a new Git repository. When I go through and take a look inside of the objects directory with tree, this is what I'm really interested in. We again can see that I have nothing in my repository because I have no objects. We can then start looking to see when our objects are being created, and by clearing our screen and then moving back to our file system, we can go ahead and create a new file within my Linux file system. Now, creating a file in the Linux file system is not going to immediately create a file in the Git repository. So when I go through and echo hello and redirect it to file 1, I also can do my ls-l and uppercase A, and I can see then that I have file 1. So yes, it is in my Linux file system and it is in my repository directory. But when I look at the contents of the repository inside of .git and objects, we can see that we still do not have a file object, or what in reality will be a blob object, created. So the file at the moment is entirely within my file system. To add it to the repository, this is where git add comes in. When I go through then and use git add file 1, I can use git add space dot for the whole directory and subdirectory, but we want to focus on this file 1. Now when we go back and run my tree command, we can see that we have indeed now created an object within my Git repository, and we can see it's SHA-1 hash. The complete hash is CE and then the long number, but we also have these directories to organize our hashes. I can use then git and cat file -p, but I only need the minimum of the first 4 characters, so CE01 will identify this file. And when we look at printing out the contents of this file, of course it's going to represent the word hello, or the contents of the file that I added. We can look at its type and we'll see that it is indeed a blob, but we'll see there are other types of objects that are going to be created. So it's a file in the file system, but it's not accessible through Git until we have a tree object. The tree objects are the entries in our directory table for Git. So we've added the file, but without a commit, we don't have the extra ancillary objects. So let's clear my screen and then run our git commit. You know, with commit, we have to have a commit message, so -m, and we can put then our message, so I'll just put it in quotes here, my first commit. But don't forget, with a commit, you are going to need the email address and author configured. But we also sometimes don't pay attention to the return screen here. When we take a look at it, we were in master, so we've committed back to the master. The root commit is showing that this is the first commit ever within the repository, so there is no parent commit. We can see the 6b41 etc. being the first characters of our SHA for the commit, and we can see then our commit message. But if we dig a little bit deeper, so let's go back and take a look at our tree command, and looking inside of .git and objects, we can see now that we have 3 objects. So CE was our original file. We can see that 6b is the SHA of the commit, but look at that, we've also got an additional entry now, D0, and D0 will be our tree object or our directory entry. So let's go through and take a look at investigating these a little bit more. And of course, we can still make use of exactly the same git cat file command. And we can go through and look at -p for printing. And then let's go through and look at 6b and 41. Remember, I only really need the first 4 characters of the hash. And we can see then, when we look at this, we can see the tree, so the tree object that it's pointing to. We can see our author and our committer and the timestamp. The timestamp is in our Linux epoch format, and we can see the time zone that I am in. I'm in the UK, and we can see that we're currently in British summertime, so GMT +1. So it's all well and good looking at the contents of this commit, but let's go through and take a look at its type with the -t. And we can see then that our file is a blob, and we can see then that our commit object is indeed a commit object. Well, okay, let's look at this other object that was created. So when we look at D001, this was our tree object, and this then contains the reference through to our file. So we can see the permissions, the file type being a blob, the SHA-1, and then the file name that should appear within the file system, so file1. And of course I can use my native Linux tool, cat, just to be able to list the contents of that file1, so that is then my word hello. So we can see how the 3 objects are linked together. The commit message linking to the tree, linking to my file. Well, let's now go through and update our file. Remember, this is a version control system. So if I append the word world through to my file1, then of course now I have edited or changed. When I look at git add and file1, we're adding that change now into my git repository. When I go back and look at tree, we can see what's changed. That I now have 2 file objects. So we have the original file object CE, but take a look, we now have a new entry 9495. So let's clear the screen just to tidy it up and just get a listing of those objects again, so we can see that it's 9495 is our new file that's been added. So if I use git cat file -p and then 94 and 95, we can see then that I'm getting the hello world coming back. And if I go through and look at the original version, so CE01, we can see then that I've got the 2 versions of my file. But again, these aren't really linked together, not until I do my commit. So let's run through the git commit -m, and then we can say that we're adding text. And we can see now when we look at our commit coming back that we're in master. We can see the parent commit, the original commit A102, my commit message, and a summary of the changes. But let's now go through and take a look at all of our objects, and we can see there has certainly been some changes, and changes that we're really now going to start diving into to understand what's going on with our Git repository. So we can see then the SHA-1 of our last commit, A102. So if we go through and use our cat file, a -p for print, and take a look at A1 and O2, now we can see the tree that it's pointing to. So 57.8D. We can see the parent commit, so 6B41. And then, of course, we have the same information, our author and committer and the timestamps. So now we can start seeing how the commits are linked back together with the parent commit. But let's go through now and take a look at printing out 57, and let's try and get 57 and 8D correct. So we can see then that this is our new blob, and it's pointing through to 9495, the file object or blob object that we were looking at before. And of course, then we can go through and print that out and see that we've got the full hello world message. And of course, within my Linux file system, we have the full message. But how can we utilize these commits? Well, let's look at our git show. This shows me the last commit. So we can see then the commit object. We can see the message. We can see then the difference between this commit and the previous commit that we added in the word world. So this does give me a lot of great information. But if those changes were complex and maybe to many files, it's not going to really help. So using git log, we can see all of the commits. Now, I only have 2, but we can see then the present commit, A102, but we can see then our previous commit, 6B and 41. Now, at the moment, we only have our master branch, so you might not think there's much point using git checkout. But I can also use git checkout to check out a previous commit. So if I go through now and do a checkout on 6B41, we can see then that it tells me, gives me a bit of warning. It's really telling me that I'm now in a read-only state. My head is detached, and that's a terrible situation to be in. But it means then I can go through and look at my file. So cat file 1, we are back at just the single line of hello. So I can go back and check to see different file versions from my file system. I can get back to my main master branch or my last commit using git and switch. We can see my previous head was at the first commit. We now switch back to our master branch, and when we look at file 1, we are back up and running with Hello World. So hopefully this gives you a better idea of what's going on when we use git add and git commit. In summary then, when we create a new file in the file system, we can use git add to add it to our Git repository. But as such, with only git add, it is not linked to any tree object, so it's not accessible by Git. So the next stage is to use git commit. With the git commit, we create a new commit object for each commit in our repository, creating also a tree object that links to our file.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.